Okay, hello everybody, and today I am going to show you a project that I've been working on. It is a game of Tic Tac Toe. Basically, just like any game of Tic Tac Toe, you got X's and O's. The player is going to be X, computer is going to be O, and he's going to use the MiniMax algorithm. If you want to learn more about it, I recommend just Google searching it. You'll find lots of information online. It basically just, I'll show you when we get to that point in the program, but it basically just looks at every single move possible, determines what's the best move. I'll start from the top. We just included basic IO stream using the namespace std. That lets us use the cout and cin functions. Then we declare a struct for a move. It's just a row and a column, and this is just for the computer to use. I could have set it up for the player as well, but I didn't. So if you want to, you're more than welcome to. Probably gonna try to post this code somewhere so I can put it in the description below, so you can access it and make this yourself if you want to make some changes to it. I do plan on making some adjustments to this and making it better, maybe putting some kind of graphical user interface or something like that as well. Alright, so let's start with the top. The first function is move left. Basically just goes through the whole array, which is a board array. I'm using a 2D array to build the board. It's a 3x3 and it's just like a grid of the tic-tac-toe board basically. So row 0, column 0 would be the top left column, row 2, column 2 would be the bottom right spot. So it basically just goes through using for loops. These are an embedded for loop, so you have a for loop with a for loop inside. This is good for going through a 2D array and checking every spot in the array. Basically what it does is check to see if there's an open spot. If there is, it returns true. If there's not, that means it'll go through this whole for loop without returning true, so it'll return false. Next one's evaluate. It basically just gives a score. Just gives a score of -10 if the player wins, +10 for the computer, and 0 for a tie. Now the reason why it gives +10 for the computer, because this is going to be used for the MiniMax algorithm for it to decide if the move's good or not. So the computer wants to see +10s, not negatives or zeros. So if he sees a +10, that means he wins. If he doesn't see a +10, that means he loses. So basically what it does, it checks to see every row in the first for loop using an if statement. It checks to see if that row has all the same value in it. If it did, then somebody won. They got their X's or O's all the way across that row. So the next thing it does is if that's true, that means that there's a winner. So then it checks to see who's the winner. Is it the computer or is it the player? After we go through all the rows, we'll go and do all the columns. Same exact thing, except it's columns instead of rows. And then we check both diagonals. There's only 2 of them, so it's not very hard to check. If there's no winner, it returns 0. So that'd be like if there's a tie, it'd be a 0. So first you want to check to see if there's empty spots, and if there is no empty spots, check to see if there's a winner. Then if there is a winner, it's either the player, the computer, or it's a tie. This here is the beginning of the MiniMax algorithm. It basically takes a board given by whatever function. Then it uses a variable called depth, which is how far down the tree, which I'll show you in a couple seconds, that a move was decided. And then it returns a max value. So it sets a score for the board after it evaluates it. Then it'll check to see what that value is and then returns it. This is used by another function to decide what the best move is. So it just decides if that move was a good move. If not, then it goes back, because it does recursive. Let me see where I'm at now. Here we go. So this is the one where it finds the best move, and we use that move struct so we can return best move row and column value for the computer. So here's where it declares best move as a move struct, and then it sets the values as -1 for both of them. So that way, if there's an error, there just won't be a move being made. You'll notice it then. And then here is where it goes through every open spot that's available and decides to check to see what the best move is. Now I'm going to bring up a drawing that I did Okay, so we'll say right here's what the board looks like. These are the possible moves the computers can make. As you can see, I did one for each possible move that he could take. Now if he does this path, this here, the player wins. So he assigns a -10 value. And the depth will be 1, because it would be just 1 more than what he already had. The next move is also player wins. So I'll get -10 as well. The next move, the player wins as well. So this here will be the only move where anything is going to go right for the computer. So the computer is going to make this move. But let's go and check why he's going to make this move. So if you look down here, there is 4 zeros and 2 10s. So the best move is going to be that move no matter what, because it's going to reach a 0 and not a -10, doing this move in one way or another. But once it gets down to here, let's just say he makes this move, and the player goes here. Well, now he has 2 choices. He can go one of these 2 paths. He's going to make this path. He's going to go put his 0 down here to block the player, which is what he should be doing, which will end in a tie. If he does take this path on his next move, the player takes this path, then there's 2 different moves for the computer as well. But they're both going to end in a tie, so it doesn't really matter. He'll probably be going with this one because it'll be the last one he's checking. Now let's just say that the player picks this move. Well, the computer is definitely going to pick this one because we've got a 0 here, a -10 here. So that's an easy decision for the computer. Alright, now we'll go back to the code again. Okay, so we got a move return for the computer to take. The next function is the print board function. This basically just prints out the board, so we don't have to keep typing this wherever we need to print the board out at. We could just type in print board and then pass the board over to it. Now here's the main function. We have a couple variables here. I was in a hurry to try to finish this so I can make a video a few days ago, and then the video didn't record, so I had a lot of problems trying to get this video done, and I haven't had time to go and put the comments in here. First one is a play variable, and this is just to see if you want to play again. That's all it's for. Then we have the player's moves for row and column. Then if there is a winner, we're using an int for that. And then the answer for if you want to play again or not are those variables. First thing we have here is it clears out the board. I was thinking about making a function for this, but it's just simple enough. I just figured I'd just leave it there. Why go through the hassle of trying to make a function for it and have it call the function when it only gets done at that one point and that one point only. So be adding to it instead of subtracting, because we're going to print the board a couple times, like at different spots. So right here it checks to see if there's any moves left or if somebody has 1. From there it'll print the board. If there is a tie, then it won't go through again. That means that the board's full and it's a tie. Well, it also checks to see if there's a tie and there's moves left. If both of these are true, it'll keep going. But if it's not a tie, it'll legs it. Or if there's no moves left, it'll legs it. So if there's no moves left, that means there was a winner, and it's either a tie or not a tie. So here, if like for first starting out, there's gonna be no. This here's both gonna be true. It's when it evaluates the board, it's gonna think it's a tie because there's no winners. And this here is gonna say that there is moves left. So this is both gonna be true. And then we'll come down here, we'll print out the board, ask you to enter your row and your column. I'm probably going to reword these, maybe change it, do something else. I was thinking about doing the graphical user interface like I said earlier, and I'll just have it where you just push a button for what space you want. Be a little user-friendly that way. So then it puts your move into the board, and then it goes and gets computer's move. I was using this for some testing because I was having some problems with where the computer was picking its move at. I couldn't quite figure it out, but I got it figured out after a while. And then it'll take the computer's move and puts that in. Next thing it does is check to see if there's a winner. Then if there's a winner, it prints out the board. Oh, this will cause, like once there's a winner, the while loop will end. That's why there's a bracket here. I just missed that, I'm sorry. But then it'll check to see if there's a winner, and then from there it'll decide what to say. So like the computer wins, it'll tell you the computer wins. The player wins, it tells you the players win. If it's a tie, I'll tell you it's a tie. And then it'll ask you if you want to play again, and I have it set up where it'll check to see if you entered in an N for no, and it doesn't matter if it's uppercase or lowercase. But if you enter no, the play variable comes false and the game is over. So let's play a couple games here quick, show you how it works. For some reason it takes a little while to load the first couple times. Alright, let's go to top left corner. Now I've played this a couple times, I know where the computer's going to go. It's going to go in the middle. Every time he'll go in the middle unless you go up to the top left, then he'll go to the top left. So let's pick our next move. I'm going to go in the bottom right. Ooh, now let's let him win. Let's go 0-2. Oh, he wanted to block me, that's why. But he should have picked... See, sometimes I'm not sure about his logic. Not sure why he picked that move, so I might have to work out through some of his logic again. I might have something wrong with that, I don't know. Oops. We want to go in row 1, column 0. Okay, so the computer won that time. Let's click yes. And we'll play again. This time I'm going to go in the bottom left right corner. He went in the middle again. Oh, if you go in the middle, he goes in the top left. That's what it is. Alright, so let's try to see if we can get a tie, because I doubt we will win. Very, very difficult to beat the computer on this one. See, I just tried to do a catch-22 type deal on him, but he kind of ruined that on me. You know what? Let's see what we could do here. Let's try the bottom left corner. Oh, he won. Alright. Let's try to see if I could fool him to try to block me. But he did block me, just it was a block to win. Alright, let's go to the middle. Let's do 1-1. So we went from the upper left. Let's do 0-2 at the top right. Okay. Let's do block him. Alright, so this isn't going to end well for us. It's going to be a no-win. He just blocked us in every way possible. Alright, so let's block him one more time. So it's a tie. Let's click no and exit. So there we go. Game over. So that is the game. Gonna post the code. Try to figure out a way to paste it. Maybe use, like, I think it's called Pastebin. I could just take the code and copy and paste it somewhere, and then you could just look at it if you want. Maybe I'll decide to do something else. I'm not quite sure. But this is a continued project. I have many other projects I want to try to get done. If you like the video, leave a like. If you want to subscribe, feel free to. And I'll see you next time.